Lunar Crater Radio Telescope Prototype 034, the Suitcase model. I'm Ken Jenks of RobotsElectric.com. In this video, we will show the Suitcase model of the Lunar Crater Radio Telescope on the far side of the Moon. In a 6-step concept of operations, we'll show the deployment and calibration of the radio telescope. We used elevation data from the actual crater on the far side of the Moon to create a 3D model of the crater. In step 1, the LCRT lander will land in the center of the crater, which is 275 meters deep. Here we'll use two models of the lunar lander, one that's large enough to see and another one that's in the same scale as the crater model. As the lunar lander approaches the crater, it uses its rocket engines to slow its forward velocity. Then it will descend vertically into the center of the crater. Here's the same motion, showing the scale model lander, represented by the small cross in the clear plastic. The lander is about 2 meters across. In step 2, the LCRT lander will launch projectile anchors to the crater rim. Each anchor trails a lift wire. Those lift wires are represented by the thick black lines in these acrylic pieces. In step 3, the LCRT lander will tighten the lift wires. The tension in the lift wires will engage the anchors with the lunar soil. Applying tension to the lift wires will also cause friction with the crater rim. In step 4, the LCRT lander will use 4 lift wires to deploy the feed antenna above the center of the crater. The 46-meter feed antenna is modeled by the triangular structure on this acrylic piece. In step 5, the LCRT lander will use 12 lift wires to deploy the large reflector so that the feed antenna is at the focal point of the reflector dish. In step 6, the Lunar Crater Radio Telescope will be calibrated with a radio signal from a CubeSat orbiting the Moon.